Welcome to the continuation of a tremendously exciting session. I wasn't actually able to get in the door, but Professor Zysman here may have comments about of a bearing about that one. We are going to move forward because of the number of people who are in this group by stages. The first stage will be about technology and models that are borne out by the historical evidence and whether or not there are breakthrough innovations that affect productivity growth. We have two speakers in the first section, which will last a half an hour. And then we have speakers whom Maria, my co-moderator, Maria Kazakova from the Gaidar Institute, will introduce, which will take on general subjects of growth as listed in the program. And that will be for 1 hour. And then finally, for the end of the session, as long as it takes, generally we expect to last till 8:15, 8:30, depending upon the questions and so forth, will be on policy. That is productivity and policy and growth. So we have some of our participants sitting in the front row. I will, at this moment, introduce only three participants, actually. Nick Harley, who will speak first. And Nick is a longtime associate of mine from the University of Oxford, where he taught economic history and directed graduate research. And he's also very well known in the field of economic history. He got his PhD with Alexander Gerschenkron at Harvard and produced fine work on shipbuilding and has since written a great deal about transportation and growth and technology. Yes, of course. The second speaker is Alessandro Nuvolari, who has also spent time at Oxford. And he is an associate professor of economic history in Sant'Anna School of Advanced Studies. His work today will be about patents and some surprising historical conclusions that they have drawn. Keep in mind they're going to be making very brief comments. Classically, they would introduce, and Nick already in a master class introduced a whole sheet of data upon which his talk actually rests. May I say also, as a commentator, we'd like Anders Åslund, who is an economist from the Atlantic Council, but nevertheless has tremendous experience in economic history, and indeed has written the basic books published in the U.S. on Russia's road to capitalism, and he was here, acted as an advisor, and he back and forth, originally from Sweden. So he has now produced a new book on Europe's challenge, growth challenge, and we'll be talking a bit later about Europe. Is that okay? Great. Nick, can you say a few words?
Okay. Let me start by saying that I think that if we're going to talk about technology and economic growth, we really want to look at the very long run. That the really fascinating question is, why are we so rich, and why did it happen relatively quickly over 2 centuries or less, and why did it only happen in a few countries, and why is it so hard for other countries to catch up? That, it seems to me, is the big question that economists really should be interested in, and I think you have to do the history seriously if you're going to answer those sorts of questions. As you all, I'm sure, know, the standard narrative is one of breakthrough technologies following one on another. There are images that I think come to mind, they certainly come to my mind, of cotton textile machinery, of the steam engine and the railways, of the Bessemer converter, of automobile assembly plants, and perhaps as we get into the present day, the silicon chip manufacturing in their sterile rooms. We sort of think of that as the narrative. It seems to be a narrative of breakthrough technologies that have broad application and drive the process of economic growth. And if we sort of think about economic growth as a more sophisticated, more economist's manner, and we start from the time of the Industrial Revolution, the end of the 18th century, and we do sources of growth calculations, what we see is that what really has caused the increase in output per capita is that output has grown more rapidly than the inputs into the production process. That's, I guess, technological change. It's certainly productivity increases, and that's really the driving force that we want to understand. So the conventional historian's narrative is this of breakthrough technologies. I think that the similar sort of tendency is present in economist growth models, that they have in mind processes that are relatively analytically tractable, which means that technology is essentially affecting everything, or at least one significant part of everything, perhaps manufacturing it off, if you want to be somewhat more specific. And it also is in the narrative of the economic consultant, that what we want to do is to generate breakthrough innovations. We want to think about what sorts of policies we should be adopting in order to generate these sorts of breakthrough technologies. Now, I'm about to say that I think this is not the way we really should understand it. If we actually go and look at the detailed historical information and think about the historical process in a disciplined way, with quantifying everything as much as we can, we find that the conventional narratives just don't fit particularly well. And there are two ways, I think, that you see this. One you might call a bottom-up way, and one you might call a top-down way. And these are things that economic historians the so-called new economic historians that were trained in quantitative methods and economic theory and became interested in growth and historical growth about, well, I hate to say it, 50, 60 years ago, since I was in the, if not the first generation, not very far behind, have brought to bear on this question. And the first point, I guess, is if you look at the so-called breakthrough innovations, it becomes clear that their impact was, in fact, really quite limited relative to the aggregate of the economy, which is what we have to drive in order to get growth. We have to drive the whole economy. We can't just drive a particular industry. So the famous cotton textile innovations, yes, textiles were the largest manufacturing industry of the late 18th, the pre-modern world. Yes, they were transformed, but even in Britain, with its vast export industry, textiles only made up about 15% of GNP at their peak. And so you're not going to double per capita income through textile innovations. You could make textiles free and you wouldn't get the kind of growth you want. Or one of the classics, the early classics of the new economic history, was Bob Fogle's work on railways. Now, I could, if I had another 15 minutes, I could probably make 30 or 40 criticisms of Fogle's work. But I don't think it would affect the point he made. The point he made, I think, is robust. That if you look at the impact of the American railroads, and you try to quantify it, he got a number that said in 1890, if you remove the railroads from the American economy and substituted other means of transportation, the American national income would be smaller by 2.7%. You could triple that number and it would still make the point that this breakthrough innovation isn't big enough to drive the economy. There are a couple of pieces of work by Nick, who's been a co-author of mine, one looking at steam quite generally from the 18th to the 19th century. The great breakthrough year in steam is usually taken as 1769, the year in which Watt's patent was taken out. In fact, as Nick von Tunzelmann showed 50 years ago, the impact is really quite modest until you get to the middle of the 19th century. There's a fairly substantial impact for a couple of generations as steam gets applied to transportation in a big way. But even if you attribute all the capital formation in that transportation revolution to the innovation and the cost savings, you still get a number that only drives a small percentage of the total growth of the economy. The same thing, and as a recent paper, it's now a working paper, I guess, at Warwick and at LSE with Crafts and Baker, and I can't remember the third person, that I've drawn on quite heavily in preparing my thoughts for today, that looks, among other things, looks at a similar calculation for the application of electricity in the United States in the early 20th century. And the results are essentially the same. That application of electricity is, of course, important, but it doesn't account for a really terribly significant part, or its impact is not a very large part of the total growth picture. You can take this and turn it the other way around. Again, and it's done, Alex Field had a book on the American economy that was published about 10 years ago, I guess, and the Baker and Crafts paper draws on this and supplements it with some additional work. Going the other way, going from the national income, total factor productivity, and going down to industries and sectors, and you can calculate total factor productivity for different sectors in the same way you do it for the economy as a whole, by comparing the growth rate of total output to the growth rate of inputs. So you get total factor productivity by industries or by sectors, and their contribution to the total the total productivity growth of the economy will be the total productivity growth in the sector multiplied by the sector's size, the sector's weight in the economy. If you do that exercise for the American economy of the first half of the 20th century, I think you'll be surprised with the industries that come out as the most important. I was surprised. The most important contributor to total factor productivity in America in the first half of the 19th century, the first half of the 20th century, was wholesale and retail trade. The second was still the railroads, although we tend to think about the railroads as a 19th century phenomenon. The third was the food processing industry. The fourth, you got to get all the way down to four before you get to transportation equipment. This is the Ford moving assembly line, which is one of the breakthrough images that we all carry into thinking about long-term growth. Then you get farming. Electrical utilities comes in at 6, and primary metals, iron and steel, comes in at 7. Now, that doesn't seem to be a story that fits terribly well with the breakthrough technology stories. You can do something similar for the post-war economy. You can also trace through, we often think about economies as manufacturing, because we have trouble conceptualizing the rest of the stuff. Things you could actually grab hold of make sense. Things that you can't grab hold of are hard to sort of quantify, hard to grasp conceptually. But manufacturing doesn't appear to be particularly special. Its total factor productivity growth is a little faster than the total economy, but not much faster. Its contribution to the growth is slightly more than its share in national income, which through advanced economies, through economies of this stage, are between, say, 25 and 30% of GMP. Manufacturing never gets much bigger than 30%. So what you've got is, I think, the conclusion is that the conclusion I would draw, and on other evidence, that in the successful economies you have technological change that is widespread, that is to a large extent independent. There are certainly connections that one can find, but it's hard to find connections, say, between cotton textiles and the Industrial Revolution and the coming of the railway in the middle of the 19th century. And I think if you think about these things, you'll find these pop up all over the place. And it seems to say that engineering breakthroughs aren't really what's the key issue here. What the key issue seems to be is a society that is able to support widespread technological change, widespread innovation that moves between industries in a largely unpredictable way, that when we look at the details of it, the technological are seldom breakthroughs of a sort of Schumpeterian type, that the finished product of the technology is invented and it gets diffused. Rather, it's one of a long period of diffusion. The steam engine, there is the Newcomen engine in the early 18th century, there's the Watt engine at the end of the century, there's the compound engines in the middle of the 19th century, there's the steam turbines at the end of the century. So what we've got, I think, if we're going to understand technological change and the process of technological change and growth, is we've got to think about the social rather than the engineering aspects of it. That how do you get a society that rewards productive, innovative activity, that discourages non-productive rent seeking? We could make this list longer, but those seem to me largely the important things. And I've been shown a 0 by my chairman, so I guess I'll better stop now.
Thanks very much, Nick. And that longer lecture was also enormously impressive. I'm still thinking about aspects of it. Our next is Alessandro Nuvolari, talking about patents.
Okay, thank you. I think what I'm going to say links really with the point that Nick has made at the end. So we have this view, or the big question is, what is rewarding innovators? So what I'm going to see is just to focus on the institutional framework of inventive activities, in particular with focus on patents. And what I'm going to do is to try to tease out some historical lessons from the history of patents. And I think that these are in some way unconventional, so they are not what maybe students of economics think they should be. Let me start with a present day concern. So currently we have seen a big policy orientation towards the increase in the scope and the strength of patent regimes. Scope in the sense that we have seen that there are more and more entities that are subjected to patents or that can be patented. Think about software, think about plants, and so on. And the strength it is that we have seen a policy shift that has made easier for patentee to enforce their rights. For example, in the United States, you have this specialized circuit court and so on. Well, all this has been driven at a global level by TRIPS and so on, and this is something that has been going on for about 20, 25 years. What is the rationale for this shift? Well, basically, it is a kind of standard, very simple model, standard textbook model of innovation. We assume that without patents, there will be rapid imitation, and this imitation will dissipate the profit of the innovators. So we need a kind of institutional device to guarantee to innovators the possibility of reaping some rewards from their investment. So this is a very simple rationale. I'm not going to discuss how accurate it is. It is also interesting to observe that there has been also an application in economic history of this view, and Douglas North has entertained the view that actually, if this is the case, if we need this institutional device, actually the creation of modern patent system can represent actually the critical institutional foundation of the Industrial Revolution. So when we have patent system, we have that innovators can invest in inventive activities because they are more or less sure to get some kind of return. Okay, also this, let me say this was not based on research, but it was much more a speculation than being based on actual research. And I think this view also is somewhat connects with the view that Knick was suggesting before, the standard narrative. So in this view, if we believe the patents are important, you also tend to think that innovation is something that is made in a certain place at a certain time by somebody. So we have this, if you want, view of technological breakthroughs and the heroes of innovation that has made the breakthroughs. And this is a very nice picture that, I don't know why this got yellow, okay. So it is an engraving of 1862, and it represents all the major inventors, heroes of the Industrial Revolution. And you can recognize that the guy sitting at the center of the stage is James Watt, and we know the story of James Watt, inventors of the steam engine and successful patentee of the steam engine. So there is this story, and of many of these innovators, you can make a story about their patents. There is a guy here on the back. Okay, oh Jesus. A guy here on the back of which you cannot see the face, because this engraving was based on the existing portrait, so you don't see the face of this guy. This guy is an engineer that is called Joseph Bramah. And Joseph Bramah had instead a very negative view of Watt's patent. He said, basically, Watt's patent has locked the brains and hands of every inventive genius that wanted to develop the steam engine, in a sense, I say. So we have seen this for the first time, this view of a negative effect of patents. So patents, it's true, they create an incentive for innovation, but they blocked subsequent developments. And if you want, I think this can be the starting point for a different view of technological change in the Industrial Revolution, but in history more generally. And this is a view in which you don't have so much the invention, or you don't look at the invention as something, as an event in time, but you look at it more as a process. Actually, you look at it more as a learning process that it takes place in a specific social context, and in which not only the innovators is involved, but you have also users of technologies, suppliers of technologies, and so on. So we have this view, and the argument I would like to put forward is that this view is gaining momentum in economic history right now, although it has not maybe been articulated in a complete way. What is the evidence supporting this, if you want, alternative view that I think it links with the point that Knick was making? Well, the point, one of the type of evidence would be that actually, if you look at the historical records, many inventions of this period were not patented. Actually, we have research by Petra Mosers. She has done through the catalog of the Crystal Palace exhibition, and she has found that only 10% of these exhibits, these were innovative exhibits, had been patented. Furthermore, we have evidence of innovators sharing knowledge. Bob Allen published a paper long ago called Collective Invention. Well, collective invention means that innovators actually not only innovate, but they share freely their knowledge. And actually, they do not take patents. So let me make an example of a big innovation that is still linked with the case of James Watt, and this is the development of the so-called Cornish engine, that is the steam engine that was used in Cornwall during the Industrial Revolution. So in the first phase, the picture is showing on the horizontal axis the years, and on the vertical axis the efficiency of steam engine. In the first phase, in the left phase, you see that there was James Watt patents was in force, so you see that you have some breakthroughs, mostly done by Watt, and you have some improvement in the efficiency of steam engine. In the second period in Cornwall, also out of resentment towards James Watt, we have the development of this collective invention regime, which is pretty much like open source today. You have these engineers, they share knowledge, and you see the big improvement in fuel efficiency. Well, is this a special exception? Mokir has recently said it is a special exception. There are very few cases. Actually, I have a recent paper in which we have collected, we are making a search, and we found all that numbers that you see on the right. And we are collecting still more cases. I would like to have a Russian case of collective invention. So please come to talk if you know of some important technology developed by Russian engineers sharing knowledge. We have also contemporary example. Let me just mention two and then I'm finished. Tesla recently, electric car, they have decided to release completely their patent portfolio in 2014. And actually the statement by Elon Musk is really keen about finding out that patents are not so important for innovation, but instead this commonly evolving technological platform is important. And Toyota has done the same. So to conclude, well, I think this new history, if you want, of the Industrial Revolution is showing that profits from innovation, so these people were making profits. It's not that we're doing. We're coming more from using and implementing technologies than from patents. That the diffusion of innovation did not dissipate innovators' profit. Think about not James Watt, but Arkwright. Arkwright had a patent. The patent was declared void. He was the richest man in England. And the diffusion and cotton mills were diffusing in spite of the patent. And also we have evidence that the conditions for knowledge sharing are not uncommon. I think there are many big implications of this, and in particular that we need today a more cautious approach towards patent policy. Let me just close on this point. I've been reading recently about Russian and TRIPS, and my impression about reading business press and also some responses is that Russia is going to take TRIPS like a bitter pill that they have to swallow and so on. Maybe you should be just more cautious and take into account some of these history lessons that I've tried to tease out. I close here. Okay, if you want.
Thanks very much. Are there any, we can have just a bit of discussion, about 5 minutes. Any questions? Should we move on to economic growth? No? Nobody's stunned as I was when I, we all sort of think about the inventor that we find major. I'm doing a work on the railroad now, trying to see if spatial analysis has, associated with works of Jeremy Atag,
Yes.
Can draw attention to its massive impact in the Midwest.
No, yeah.
There's a literature that builds, I think, on the economic history and adds like case studies. I'm thinking of Acemoglu in particular, his latest book, Robinson. And there, the point is that he does not just look at the growth, but at the durability as well, or as we might say, the sustainability of growth. And there he introduces a lot of institutional elements, so patents and more broadly, whether the society can share the fruits of innovation and growth, or on the contrary, that they are extractive. So that's a kind of a dichotomy that does not go against what you said, but kind of builds on it. Just thought I'd make the point.
I guess I'd just like to comment, and I think that's very important, although I suspect that if a society does fall into the extractive bin, the growth doesn't work.
That's exactly the point. It doesn't sustain.
It doesn't sustain.
It may happen, but then it
Yes.
That's exactly
Just quickly, I think, yes, I think the logic of the argument of Acemoglu and so on, it is probably correct. I have some doubts more on their history. So one could make the case actually that patents in this period, they point them out as an inclusive institution. Actually, it was probably more extractive, if you read actually the actual documents. It was something that elite used. For example, think about the case of James Watt. James Watt is able to win a case in court, not because the legal system was working well, but actually because the legal system was favoring people that were gentlemen and so on and so forth. So we should look at, don't do the mistake of look institutions that have a certain purpose today, like they were working in the same way. No, of course. No, yeah.
I'm trying to disagree with you guys.
Possible to take your work or a lot of the sources that you cited, and particularly when you talk about breaking it down by sector and contributions to overall factor productivity, could you go totally the other way around and say that the non-implementation or non-development of a particular type of technology that elsewhere is thought to be breakthrough or sort of epoch-defining? And here I'm thinking in particular of an argument that's often made. I'm not a huge fan of it, but something along the lines of the Soviet Union lost the second half of the 20th century economic competition because their computers weren't as good as American computers. So say very simplistically, could you turn it around and say, well, actually, you know, that's not as big of a percentage contribution to an overall advance or lag? Can you flip it around in that direction? Thank you.
I would think you can. I think that that the story, the moral, I guess, of the story I'm trying to tell is that, at least in these historical examples that I've talked about, that technological progress is not concentrated in some particular engineering elements. It's a broad process of a society that can sustain development, technological development, productivity increases across a wide range of sectors, often, I think, to a large extent, unpredictably in their specific areas, and very often generated in large measure by learning by doing, and the same sort of thing that Alessandro was saying here. And patents are these fascinating things because it does incentivize inventive activity, but it also becomes an extractive, a rent-seeking part of the process, and all these issues about knowledge and the nature of knowledge, the externalities of knowledge, the public good nature of knowledge, and the need to incentivize creation of knowledge are, I think, crucial issues that we need to think about, but I don't think we can overstress them, that the learning by doing and the collective invention sorts of issues are really key here. And if you think about the technological contribution of wholesale and retail trade, that presumably is lots of relatively small shopkeepers adapting new things, small, inefficient shops being driven out of business, and that sort of process of entry and exit, efficient market operations seem to be a part of the productivity growth process that we should take seriously.
We have one small comment.
No, yes, it would be
Alessandro,
actually a question for Nick. So if we take this, your point from the perspective of catching up countries, Yeah, usually now what we had seen in history has been very much a focus on sectoral policies, actually. But in the 19th century for military reasons. So you want to have, I don't know, the dreadnoughts. You want to have but also for economic reasons. There was this idea of these leading sectors and so on. So I would like to ask you, your perspective, how does it sound from this type of policy? Because we see it even now. For example, Indonesia, they have wasted a lot of money to build, they wanted to be able to manufacture planes and so on. So these...
No, I think that this is very much within the framework. I hesitate to talk too much about that because I know a lot about Britain and the United States, and I don't know a lot about other things. But the catch-up, the problems of catch-up, are clearly part of the same thing. That in the 19th century, you could buy exactly the same technology, exactly the same machinery from the machine makers in Liverpool, bring them to Moscow. The machinery manufacturers would install it. They would send foremen to train the labor force. Yet it doesn't have the effect of driving a takeoff.
Thanks very much. We have to go on to the next section now, which Maria Kazakova will.
Yeah, thank you, dear participants, for your excellent discussion. If I may, I will moderate in Russian.
Yes, конечно.
Thank you.
Our discussion is called the factor of economic growth and productivity. And unlike previous participants, we want to concentrate not on historical aspects of economic growth, and on the contemporary growth and the search for its stimulation in Russia, the role of institutes of increased exports, and the capability of Russian firms to achieve breakthrough, technological breakthrough. This question commanded a lot of attention in the past, but the new approaches, one of the participants of our discussion will talk about the aspects of export by Ricardo Hausmann of Harvard University. The science reached new results which allow us to give answers to these questions which recently have acquired central importance for Russia against the background of shocks such as reduced oil prices and so on. So before we move to the reports of our participants, I would like to give the floor to Mr. Chris Papageorgiou, Международный валютный фонд.
Thank you very much. I'd like to bring a slightly different perspective on the question of growth, but very much building on what Knick and Alessandro talked about, especially in terms of productivity. I'd like to come from the perspective of a macroeconomist, since I'm coming from the IMF, from the International Monetary Fund, and I think this will link very well for the next session, which is on policies, but I'll hold a bit short on the policies as we come to the next section. I wanted to provide a bit of a context on how macroeconomists have been thinking about the issues of productivity, and also another big issue which recently is extremely very much in the discussion, which is the process of structural transformation. So this whole literature, and with it the policy discussion, started about 30 years ago, when we started as macroeconomists to think about economic growth and to start think what are the right policies that these big institutions like the World Bank and the IMF could provide to member states. And early on, we knew very little. Many of you, I see students here, you can remember the papers by Lucas and Romer going back 30 years. Those papers basically had in mind ways by which you can improve growth, sustain growth, and a little later on make growth more inclusive. So the problem with that approach was that we recognized that policies that came out of these models were very general. Well, I can give you examples. We would go to countries and would tell them, you need to increase human capital, or you need to increase institutional levels. And of course, country prime ministers, ministers of finance, and central bankers would look at us and say, but of course, what else? What else can you say? So it took us about 30 years to start digging more deeper into these drivers of growth. And I think we haven't solved the problem of growth, but we came a long way. And here I want to talk about these two important factors that probably you'll hear again and again in the discussions. One is the issue of productivity. After a lot of work, we got to realize that that's the main factor, that's the main driver of growth. Not so much for low-income countries, and we can discuss this separately, more so for emerging markets and advanced economies. This is what drives growth, it's productivity. And by productivity, at least from the macro perspective, we are thinking how with the same number of inputs, capital and labor, you can make the economy have more value added. You know, not increasing the skill level necessarily or the capital stock, but given this capital stock, how you increase productivity. The second, which is perhaps more important, but again, as macroeconomists, we come very late in the game, is this issue of structural transformation. It took us decades to catch on that. This is a very well-known theory by development economists. But we recognize now that unless we put this productivity story in the context of structural transformation, we cannot adequately provide policies. And this is what I want to focus a little bit for 2 minutes. What do we mean by structural transformation? We recognize now, as we see our 183 member states, is that they fit into different groups. They are not all behaving the same. So when you think about low-income countries, they are very different than emerging markets. So think about a country like Angola or Ghana. It's not very different than Brazil and China, and it's very different than the United States and Russia, for example. So structural transformation is trying to recognize that these countries probably will behave differently also on the aspect of productivity along this transformation path. So, and to go a bit on the way that Knick went, we go one level down below overall growth of GDP. We go to sectors. So we start thinking growth in terms of agriculture, manufacturing, and services. And again, I'm thinking Ghana is more an agricultural country, you know, China is more of a manufacturing country, and the United States and probably Russia is more of a services country. So with this realization in 2015, so many years later, both the bank but also the fund came out with what I think is a much more appropriate picture of policies that can tackle productivity for countries that move along this process of structural transformation. And with that, I will close my remarks and I'll keep something to say a bit later on policies. Thank you.
Thank you, Chris. Итак, я предлагаю передать...
I would like to give the floor to the speakers. The first floor is given to Ivan Lyubimov, senior researcher of Gaidar Institute. He deals with such questions as economic growth, economic development. He has publications on that question in the New Economic Association, economic policies, and so on. Today he is going to tell us about the role of expert structure and the institutions that are needed to stimulate economic growth. Ivan, please.
Speaking in English, so my presentation is not about global issues, but about a particular economy, and I hope We will have it in a second on the screen. Yes, thank you very much. So I would like to start from quite well-known and basic things. There is a quite well-known study which was published in American Economic Review, which says that as long as an economy belongs to a group of relatively less developed economies, diversification is more important than concentration, than specialization. So to grow until the level of approximately Portugal in terms of GDP per capita, we'd better first to increase our export basket, and then, only then, after we reach a particular threshold, after that, then we specialize. So then we have quite an intriguing task and a complex task. How do we diversify? What kind of products do we add to our export basket? Why is it an intriguing, important, and complex task, knowing what kind of products should we export next? First of all, we have a dilemma. Let's assume we are a low-developed economy which produces and exports something what belongs to agriculture or commodities, right? Oil, and perhaps textile as well. So the simplest way to diversify is to add something close to what we already can produce, something adjacent to our export basket. If we can produce T-shirts, we can produce something belonging to the textile industry, because we have all ingredients of almost all capabilities to expand the nomenclatura, the set of our textile goods. But if we want to develop further, if we want a sustainable development, then we need to know how to produce more complex goods and how to export them, which is much more important than merely to produce goods. And then we need to take risk and try to expand into the product space a bit further, learn how to export something more technologically complicated. So economists know approximately how a particular economy can develop, and I will explain what this slide means, what is depicted here. So this slide is a result of quite popular among applied economists approach, which was developed at Harvard University by Hausman, Danny Roderick, and in cooperation with people from MIT, such, for instance, Hidalgo, which is mentioned here. So this is a product space. Each node reflects a product which is exported in the world. And in the periphery of this product space, there are simple goods, such as garment, such as commodity products, such as agricultural products, and so on. And in the core part of it, more complex goods are concentrated. And less developed economies, they export goods which belong to the periphery, while more developed economies export goods which are in the center of this product space. And the ambition of every developing economy is to move from here, from periphery, to the center, from here to the center, from here to the center. And we can see that this is the case. So here we have the same picture where black dots, black squares, correspond to what developed economies are exporting. And we can see that they export everything. They export technologically advanced goods, and they export simple goods as well. While less developed economies, such as African economies, they export they export simple goods, and the core for this group of economies is empty. We can't see too many advanced goods, technologically advanced goods in the core of the product space if we talk about less developed economies. So I think the same problem we have now in Russia. World Bank almost continuously emphasizes that diversification is a necessary step if we would like to reach sustainable growth. So we have to learn how to produce more complex goods, more technologically advanced goods, in order to become more developed and a richer economy. So let me introduce briefly what we have already done about that. We collected export data about Russian regions and about the global economy, and decided to consider Russian regions as if they are countries, part of the global economy, because then we can collect much more information about products, how complex they are, or how less complex they are. And we were able to estimate how complex are the economies of Russian regions. And in this map, more dark blue regions are more technologically developed. They produce more export more complex goods than less dark blue regions. And what is more important is to estimate the perspectives, the future of these regions. And this future is very much correlated, is very much correlated with what these what these regional economies can produce today. The more advanced, the more complex their economies are, there are more chances that they can transit to even more complex products and to more advanced exports. It's consistent with what Hausman and Dalgo and their co-authors received in a series of their papers. So next very important thing is to not only to find out what is the closest node to say this one. For instance, Russia can produce this product, and the closest one is that one. It's also important to know which capabilities we have to build in order to transit to this next product. Why it is important? Because some capabilities are changing in Russia very slowly. Property rights protection and these days global issues might make building a particular capability more difficult than other capabilities. So property rights is very important for technologically developed goods, and unless we have them improved, it's not very likely that we can build capital-intensive capabilities, because investing into capital requires reliable protection of property rights. So we expect then that we will be developing labor-intensive industries with lower probability to reach the world market. So now our next ambition, our next research step is not only to learn what every Russian region can potentially produce given its export basket, but also how likely that a particular capability, a particular ingredient can be built in a particular region. And then we would like to aggregate our inferences to the level of national Russian economy. So to conclude, I will be concluding now. What should be done? So there are a lot of general recommendations, such as let's improve property rights, let's increase the stock of human capital, and let's improve infrastructure. We would like to go deeply till the level of a product group to know what exactly should be improved with respect to this product group to make it possible to export products belonging to this group. So, and we have already done a part of this task. Thank you very much.
Спасибо, Иван. Ну, на самом деле, проблема качества институтов, технологического...
Thank you, Ivan. But diversification and increase of export potential and further economic growth, they are very topical for Russia. But in fact, these issues can be dealt with well, let us take one question. We thought that the questions will be asked later. We take one question. Thank you very much. Very interesting presentation. With your permission, I will speak Russian. The model is very beautiful and fancy and easy for remembering it. But to assess to what extent it is correct and how to understand it better, we would like to see an example. Say, if we take Japan in the mid-60s, 2060s, well, the Japanese all of a sudden, please be brief. The Japanese started exporting cars and electronic goods. And in what way this decision was substantiated based on this model? Thank you for the question. I will answer in Russian. This model was non-existent at that time. This model is only 10 years old, and but there are assessments in what way Taiwan, South Korea, or Japan behaved according to this model, unlike other economies, which, while being very simple, and how they could pass over to something complicated. This was very risky and it required much expense. If you were majoring in textile and you want to start producing cars, so you have to produce some new components which you cannot say compete with other countries. So at the in the years of 60s and 70s of 20s, so South Korea, namely, unlike Japan, it started to produce something adjacent to what they have produced, to their common goods. And then they passed over to more and more complicated things. So they build up their more complicated industry gradually. So just in order to be able to produce all components necessary for that. And the Japanese, they behaved in a similar way, but they exported simple goods as well. At the start, and then they passed over to more complicated. Let us continue this after reports. Well, I would like to pass the floor to the next speaker. In fact, I wanted to say that the problem which was tackled by Ivan in his report, it can be analyzed not only at the level of a country and its regional, its separate regions, but at the level of sectors. I pass the floor to Ilya Voskoboynikov, senior researcher of the Institute of Economy, and he's dealing with economic growth, economic development, economic history, economic statistics, and he has publications in journal and economic issues and others. And now he will analyze the changes in the sources of growth at the level of sectors. If I said something wrong, so please correct me.
Here and well, I will continue in English. Actually, my presentation is continues the line which was suggested by many speakers in this room. I appreciate Knick who introduced us with this growth accounting framework which decomposes growth into contributions of labor, capital, and total factor productivity. This is exactly what I'm going to use for the analysis of the Russian economy now. And also Chris, who highlighted the importance of structural change and the link between the structural change and growth. I will also consider this taking into account the Russian economy. And actually, what I'm going to do here is mentioned in the title of this session, what is really going on? So I'm going to answer this question. This is the long-run growth of the Russian economy starting from early 60s. So basically we see the trend of real GDP starting from 1961 up to 2021 according to the projection of the International Monetary Fund. Interestingly, the average growth rates of the Russian economy for this period was about 2.96%, which is just around the average growth rate of the United States for the same years. Basically, the United States grew with rates of 3.07. But the difference is in variations. Russian growth is extremely volatile. We observe long-run growth before transition, then the transformational fall when in 1998 the level of Russian GDP was just of 60% of 1990, and then growth with different rates before the first financial crisis, between the financial crises and the stagnation which we observe now. In this presentation, I will focus on the period starting from 1995 up to 2012. And in some aspects up to 2014. And I start from the end, just saying what are main sources and main drivers of growth if we use this growth accounting framework. Basically, Russian growth is mostly driven by capital intensity in extended mining and some market services. This is the most important source which actually worked both before 2008 and after the crisis. The second step is technological catching up But this catching up took place not so much in manufacturing, but much more in business services and business and financial services, but also in manufacturing. Then the important source of growth is also labor allocation. What does it mean? If workers shift industries and if a worker leaves a job in an industry with a low productivity and it goes to and he or she goes to the industry with high productivity, we will see this in aggregate numbers, in the numbers of aggregate growth. Taking into account that planned economy was extremely distorted and transition was also the process of structural change into the more balanced model, in principle, we can expect that the contribution of labor reallocation will be high. To a certain extent, it's true, but in reality, the effect of labor reallocation is not as high, and this is not only for the Russian economy, but also for many economies in transition, which we will see. Labor composition is something which is broadly discussed in this conference. In particular, well, labor composition is a change of allocation of hours worked between different groups with different levels of education, age, and gender. If hours worked are allocated in favor of more productive groups, labor composition goes up. Basically, this is something which was mentioned in the report of the World Bank, which was presented in the first day of the conference, where people said, okay, it's important, human capital is an important source for Russian growth. In this presentation, we will see, indeed, it is important, but its contribution, its direct contribution is not so high. And finally, labor can reallocate not only between different industries, but also between formal and informal segments within industries. This is also the important topic of this conference. Even in the first day of the conference, many people mentioned that informality is one of the problems of the Russian economy. We will see how it works in growth numbers and how it influences aggregated growth. Basically, this table represents growth accounting decomposition at the aggregate level for the Russian economy. Well, it starts from aggregate real GDP growth. For example, for the whole period in question, it was 3.7% on the average, which can be decomposed into different contributions. The first point, I'm talking about the last column on this picture. The first row is just the contribution of hours worked. It is extremely small. Russia is the economy which passed the period of the Industrial Revolution, so basically we don't expect too much from the inflow of labor force. The next row highlights is a labor productivity, the contribution of aggregate labor productivity. Well, as it was mentioned many times, productivity drives everything. Aggregated labor productivity can be decomposed into labor allocation, basically the outcome of structural change to growth, which is in total substantial, then 0.76 percentage points. And intra-industry growth which is driven by internal sources within industries, such as the inflow of capital intensity, labor composition, the improvements in the composition and the performance of labor force, and finally, multi-factor or total factor productivity. What does it mean? It means just the ability of the economy to diminish real costs of production. Anyways, because of technological improvements or some improvements in business processes, anyway. And these numbers for the whole period show that the contribution of multi-factor productivity was a bit lower in comparison with capital intensity. Basically, Russian growth for this period remains extensive. If we highlight main sources of growth for the whole period, we will see that actually in first years of, not first, but actually on the first stage of transition, main driver of growth, main positive driver of growth was total factor productivity, as well as the period before the first financial crisis. At the same time, there is a puzzle for the Russian economy, which it can be somehow resolved for the column of 2003 and 2007. The puzzle is, we know that Russian growth should depend somehow on prices of oil and gas, and in particular on the inflow of oil and gas to the Russian economy. Oh, is it 0 for me, Masha?
No, 5.
No.
5, thanks.
You have a chance.
Be careful next time.
Sorry.
So the puzzle is, if Russia depends on oil and gas, what does it mean that in many papers of growth accounting of the Russian economy, the main driver of Russian growth is actually TFP? Is it possible to diminish costs with the inflow of oil and gas money? And the answer is, if we measure factors of production better, and we do it better in this paper, we shift to capital services, we will see that actually capital intensity also plays a role, at least for years of soaring oil and gas prices. And finally, at the final stage, at the stagnation stage, only this source, the extensive growth because of oil, gas, and some retail, remains more or less stable. Labor composition is just a permanent driver of growth, but we can see that only 0.2 percentage points are contributed by it. What is this in terms of the industrial structure of growth? I'm not going to shift tables, I'm going just to tell you a story. If we're talking about MFP, drivers of sources of multi-factor productivity of the Russian economy before 2008 are basically business services, financial services, and manufacturing. In business services, it can be explained by a very low initial level of the services, let's say in 1995, even in comparison with some other European economies in transition. Think of, let's say, banking services. We didn't have lots of credits and even credit cards in 1995, but we have a lot of them now. So basically, it doesn't mean that we provide some global innovations. It means just we adapt some technologies and gain from this in terms of TFP growth. By 2008, this source of growth was more or less exhausted. Manufacturing is a bit different story. We observe some convergence here in manufacturing, but in Russian manufacturing is shrinking. That's why, in spite of the fact that in principle it is efficient, its contribution to the aggregate growth is relatively small. Okay, thanks. And finally, if we go to capital intensity, two main sectors which contribute to capital intensity are low-skilled intensive services, such as retail, and also oil and gas, along with the wholesale trade. So basically, these are two main sources. And finally, I wanted to stress the point about reallocation. In this picture, I show the contribution of labor reallocation into aggregate growth. And this for European transition economies, including Russia. Russia is here. And this reallocation is also, so basically there are three effects within, something like within industry sources of growth, and also reallocation, which is the sum of red and green parts of the bars. The reallocation can be of two types. The first one is workers could relocate in industries with different levels of productivity, which is called the Denison effect. And also workers could relocate between industries with different types of growth, which is growth rates of productivity, which is the Baumol effect. The short summary of this picture is the total effect of labor allocation is minor in comparison with the aggregate productivity growth, and it also somehow cancelled by reallocation to services, which are less productive in comparison with manufacturing. And also reallocation from the formal to the informal segment, which I observe in the Russian economy, diminishes the contribution of reallocation to growth. So basically, I'm going to finish. Basically, all results, I have just highlighted some points about sources of growth of the Russian economy, capital intensity in some sectors, technology catching on in some other sectors, labor allocation, labor composition, and informality. Well, and all these results can be compared across countries at the level of industries within the World Claims database, because calculations for Russia are based on the Russian segment of this database. Thanks.
Спасибо большое. This is brilliant. Спасибо, Илья. Я предлагаю послушать нашего третьего.
It was brilliant, and I give the floor to the third speaker, Anna Fedinina, the chief researcher from St. Petersburg. She had publications on international trade, regional economy, trade politics in various magazines and newspapers. Anna will speak on factors of success of quickly growing aspects. Thank you very much. I would like to present intermediate results of research of economy. We research quickly growing enterprises. Why we do that? Because within the framework of, do you hear me? Within the framework of plenary meeting, it was said that the growth rates of Russian economy are the lowest over the recent years. But are there enterprises which are technologically active and which grow much faster than the economy as a whole? And how many of those enterprises, in which regions they are located, and what are they? This is the first approach in looking for technological factors of growth for, say, Gazelle. And what we mean by Gazelle is quickly growing enterprises and companies. On the whole, there are many quickly growing in various countries of the world, and these are enterprises which have gained more than 20% of growth over the 3 years running. So on the average in various economies, and so emerging economies and developing economies, there are about 5 to 6% of these quickly growing enterprises. They are dynamically growing. They are small and medium-sized enterprises, and they account for 50% of growth for employment. That's why when we speak about the economic growth in Russia, we have to assess whether there are dynamically developing enterprises which are capable to make important contribution into economic growth. Second, what is important, there are no clear-cut determination in what way you can become a dynamically growing enterprise. And the possibility for that is incidental. It is not predictable, because it is based on very many factors, and we would like to see what happens in Russia with dynamically developing enterprises, and are they at all or not. And world assessment with regard to these enterprises show that they are young enterprises which grow in sectors having some relative advantages. We do not project many such enterprises in high-tech industries. If we take some rating of quickly growing enterprises, and there's rating of top 500 quickly growing growth, so they are mainly located in Europe and in US, and in Russia there are only 3 such enterprises, so we are lagging behind considerably from the leading countries, and we attribute the following factors to the growth. Because the classification is non-existent. What are the factors which ensure weak growth rates? So there are technological aspects, internal technological resources. These are new labor resources, material resources, some external resource factors which we belong to export activity and direct foreign investment, and a number of non-technological factors like environment, institutional factors, the quality of the conditions for entrepreneurial activity, then infrastructure, and regional factors related to human resources and human activity. Because in those agglomerations where the high-level education people are concentrated more, the probability for quickly growing enterprises is higher. So we've taken the numbers for 2014 and how many enterprises were the enterprises which grow 20% a year. So we found 8,300 companies which but the final choice is that there are 5,800 enterprises which grow at 20% a year. But 1,200 enterprises in manufacturing industries and 5.8 thousand companies. Is it much or not for the Russian economy? So by the end of 2014, there were 505,500,000 small and medium-sized businesses. Well, in what regions these dynamically developing enterprises are located? So you see here, first of all, the regions with high concentration of manufacturing industries. And if we see the high concentration of dynamically growing enterprises or gazelles, and if we assess, say, how many those enterprises per 10,000 average enterprises, so Moscow region takes the leading place, and out of 13th place, here we see the industrially developed regions, those exporters, and I believe that the exporters must be located close to borders and foreign markets, but no, they are concentrated in other regions where the industrial growth is higher than in other regions. And I already mentioned that by foreign assessment, the concentration of those enterprises in manufacturing industries, and you see that there are 3 sectors, but what is true that for the Russian economy, what industries are important is chemical industry, then the food industry, and manufacturing industry or machine building industries. And these results are fairly surprising, because those gazelle exporters and the gazelles which have foreign investments in them, they are also concentrated in those three industries. And here's a small slide showing that gazelles are located mainly in such industries as textile industry in Ivanovo region, which has been always specialized in textile industry, then Krasnodar region, and which concentrates or focuses on agriculture. And I won't dwell upon methodological of assessment, and I will pass over to the results. What have we achieved? We see here the assessments, the coefficient of gazelles among the among the sectors and regions. You see these in blue, if the enterprise is an exporting and quickly growing, so such enterprises give a good growth. Then you see the indicator of the precedes growth. If we look at studies showing the growth of enterprises, what is more important is the productivity of enterprises, and we are busy in assessing the productivity of enterprises, but at least by marginal sales, which can be viewed as an effect, as kind of effectiveness of enterprise. What is important that exporting enterprises are more effective than in average than other factories. If we compare the net income and proceeds, and the outcome of the results of enterprises with foreign participation, foreign investment. The first result is unusual, and that direct foreign investment does not affect the enterprise growth with regard to gazelles. Maybe this is attributed to the fact that the foreign investment to that or another extent are not the drivers for enterprise growth. But what is important that the additional technologies which involve foreign investment give the possibility for higher growth. And if an enterprise has a status of enterprise with foreign investment, then marginal growth is a little bit higher than the average. And I believe that I keep with the time allocated to me. Well, first of all, what we have here, the technological development of gazelles is, first of all, in well-developed regions, and not all the regions are prepared to become the drivers for those gazelles enterprises. What is also important that these enterprises develop in economically developed regions, and that we have to continue to develop big agglomerates and economic entities which serve as drivers for the economic growth as a whole. And to conclude with, I would like to say, if we speak about the recommendations, so what is evident is that in future, the development of these gazelles or dynamically grown enterprises and the chances to reach 5 or 6% growth or expansion of those enterprises. So it will depend on a number of factors, including whether today's economic policy bring down the expense as a whole will be successful, and it will stimulate the business as a whole. And if the as far as to the export growth, we are on the 150th place, which is not that good. This is all I wanted to mention. I am prepared for your comments.
I have two questions for the two speakers. The first question, I'm not an expert on economic growth, but when you compare disaggregated economic growth, maybe I misunderstood something. This fall in the span of 2008-2012, you linked it to the factors of technological growth that did not work. Maybe I misunderstood you, but I think that it is quite evident that this is the effect of the lower oil prices. This is my question. And I have a question. I have many questions addressed to Anna. My name is Stepan Zimtsov. We also did some research as far as gazelles are concerned. And the first question is the influence of inflation. And have you taken into account the rate of jobs, employment? Then the question is, can the companies in the sample with zero employment grow at 20 or 30%? Thank you. Can I answer? Yes. Thank you for your question. In reality, the system of account of economic growth does not allow us directly to link the fall in output with the lowering oil prices. This is a sum total of various factors, capital and others. If there is a lower growth for a number of reasons, including the lower oil prices, it should be reflected in some way in one of the factors of production. The results that have been presented demonstrate that in many cases our task is to explain this. How can I explain this? There are two ways to explain it. The first one is that at the stage of decrease, the accounts of economic growth do not work well. This is linked to our inability to adequately measure the capital. The access to capital is also one of the reasons. I do not want to make an accent on the technological degradation. I would like to emphasize what Harberger suggested. It is not necessarily the degradation of technologies, but the fact that the economy is less capable or to reduce costs of production. And the last thing, we have to be very careful in interpretation this phenomenon. But the main information is that in the period from 2008, TFP ceased to be the serious source. I wanted to add something to I think it is very. Yep.
The bad companies,
Крупные компании. Это как раз противное отношение того, что произошло.
they were saved. So therefore, you would expect a sharp fall in TFP.
Thank you.
Я тогда отвечу на еще два вопроса. Ваш первая часть.
I will answer the first question. You asked about inflation. No, we did not take into account the inflation rate. The status does take into account the inflation. We did not take it into account. As far as employment is concerned, it is clear that there are two approaches. The determination of status in accordance with the profit. I cannot believe that such an important share of enterprises has zero employment. There are no data. I think these are some kind of gray enterprises, gray sector. We have tried to find out whether this enterprise is active. If we judge by employment, the number of sample enterprises are reduced. I have a number of questions about these enterprises. As far as I understood from this report, you said that the contribution of gazelles in the what kind of contribution is this? 30 or 40% is gazelles account for this growth. The second question is, how does successful economic policy correspond to the conditions, favorable conditions for the development of gazelles? And the third question, if this depends on the development of gazelles, then why economically developed countries, the conditions for gazelles are better? Why the rate of economic development are lower? Thank you for these questions. First, the contribution of gazelle enterprises in the economy. The assessment that I have shown, 5% of all the medium business, 50% of employment. And we don't have this kind of assessment in terms of growth because it's very difficult. We associate the creation of new jobs because these enterprises are linked to innovations. the definition of these enterprises. The speaker is not using microphone. Cannot be heard. Then I wouldn't say that. I don't think this is a correct assessment. The contribution of small and medium enterprises in the economy of Russia is pretty low. In European countries, small and medium enterprises account for 60–80%. We have less than 30%. I don't want to produce any numerical assessment. The second question concerned the institutions that provide for gazelles. In reality, I believe that there is no definite answer in various countries. In different countries and in different types of economies, the factors that account for the growth. But there should be a trend. Can I finish my answer? And then you will. In reality, the idea is in developed countries, in developing economies where the level of competition and the conditions for competition are at a good level, gazelles appear by themselves because of the good institutes, because of the low costs for entering the market. This is the case of the Russian economy. The gazelle enterprises appear as a result that they affiliate with government. The factors that determine the growth of these enterprises are the same for all the countries. But to create favorable conditions means lowering the barriers for entering the market. And going back to your second question about the economic policy, I think that 2016 was a turning point when we started facing the small and the medium-sized enterprises. It's an important event. And another important event is the project to support speedily growing exporters. The creation of 15 high-tech enterprises by the year 2020. In this sense, steps in growing these enterprises do exist. We will probably see the fruit. Maybe you can exchange contacts, because the subject can be discussed for a long time, and even 3 hours are not enough. I suggest that we close the question and answer sessions. And to sum up our discussion, all the reports are interconnected. They, in one way or another, speak about the sources of growth, which are coordinated among themselves. In reality, economic growth is closely linked with the capability of the economy to increase production. And the factors of such efficiency are new breakthrough technologies and the possibility to use export diversification and the institutes that support innovation and development. And each country has a specific traits of their own. In many aspects, breakthrough technologies give different economic effect, have different economic effects, and for different countries, different directions of diversification of export are preferable to achieve best results. And in different countries, there are different levels of development of institutions and different limitations for economic growth. And detailed determination of the most rigid limitations is diagnostic of growth. I suggest that we leave it for future roundtable discussions. I would like to thank our participants and the audience for a very useful discussion, and to give the floor to the participants of the third session.
Thank you. We'll be moving on now. If the participants of the third part.
Do you have any ideas? Which speakers will...
Maybe, yeah. Well.
Start fast, otherwise you lose the whole audience.
What?
Start fast, otherwise you lose the whole audience.
I didn't hear you. Yes.
Thank you for your comments. I appreciate that. That's a good idea.
Yeah, and I think there was something else also. Yeah, we already...
Okay, let's begin the next session. May I please introduce participants in this session? John Zysman, professor at the University of California-Berkeley, the founding director of the Berkeley Roundtable on International Economics. And he draws attention to his book, Governments, Markets, and Growth. And he's one of the foremost authorities in the United States on this topic. We also have Chris will remain on this panel. And would you like to introduce Mathilde?
I will speak French, if I may. Madame Mesnard, bienvenue à notre table ronde. Nous sommes très heureux de vous voir entre nous.
Okay. Who would like to begin? Would you? Yeah.
Would you like me to begin? Yeah. Well, since it's late and those of you who've stayed have been very gracious, I want to entertain you with what my friend Ray de Machado points out is now the new chic, which is narrative economics. And I want to try and integrate this comments that have been made until now into sort of a narrative about this story.
Could you please switch on your microphone?
I would be delighted to. I'm going to try and tell a narrative that integrates the sets of issues that have been raised so far. The first question, and it comes out of listening to the earlier session and to other comments during this forum, there's a tremendous tendency in looking at technologies to fantasize about how they're going to evolve over time. And I would warn us all against that sort of cyclical fantasies. The driverless car is somewhat equivalent to the flying car of 30 or 40 years ago. We can think out 3 to 6 years maximum in thinking through the impact of technologies. That said, an important part of what technologies do is not the actual amount spent on railroads or the amount spent on cotton. It is the way in which they change the possibilities throughout an economy. the way in which they change the options, the cost structures, that then lead to a whole array of other kinds of changes in the economy. Where I grew up in Omaha, Nebraska, and I should say that the cold here is very familiar to me, so I'm very comfortable with it. But where I grew up in Omaha, Nebraska, when the railroad gave way to the interstate highway, there was suddenly an entire building boom in the city as in all of the enterprises moved from being located around the railhead to being located at the intersection of the north-south highway, driving an enormous amount of investment and changes in productivity. So that said, I want to emphasize that the two areas of technology that I think I'm going to lead into policy with this, the areas of technology that are going to drive growth over the next years and transformation of the economy are computing abundance, the enormous fact that, in fact, computing not only emerged, but in fact has gone from being a very high-cost, rigidly limited available commodity to being something that's enormously available, really in the form of cloud computing, which I'm going to talk about tomorrow. And the second is the emergence of renewable energy over time, which are both going to change options throughout the economy in quite predictable ways. And that leads into the comments that were made earlier, which is that the ability to take advantage of these things depend very much on rules which exist, rules which then may in fact have to be created, and in the controversies about those rules, both, and I should say it's not just patent law, but the fights about patent law and whether it's applicable. But for those of you who are familiar, I'm from California. I live in Silicon Valley, so the world of gazelles is a world that's fairly conventional to me. What is very interesting to me is it's not just those companies which here are related to the state. In many cases, the gazelles in California are taking a challenge to the state. There is a wonderful comment about Uber, which is much less of an interesting company than you may think. But there's a tremendous challenge from Uber, and that comes into the conventional comments made in Silicon Valley. Don't ask permission, ask forgiveness. Do what you want, drive the rules after the fact. Now, you don't always get forgiveness, and you don't always get away with it, but it's a very different attitude if you don't take it literally, but take it as an attitude. So that the question really is in these technologies, it is how do they impact the broader economy through development, 3 Ds, development, diffusion, and deployment. And I think that the real instance here is what happened in microelectronics. We start with the chip. The chip gives way to the DARPA. I'm oversimplifying 50 years of history. The chip gives way to the DARPANet, which is the early and then gives way to the internet, which then is commercialized, and it really becomes a powerhouse when the World Wide Web is associated with it. It's a longer story that starts to change the options, and that story is now being accelerated by the emergence of cloud computing. For those of you who don't know, cloud computing is not where you do computing, it's how you do computing, and it lowers the cost of computing and widens its availability in very dramatic ways. And for renewables, the similar issue about this is that you go from, if you're going to have renewables, from a centralized grid to a decentralized grid. It's a set of associated and related technologies radically changing things. Now, all of that requires transformations of the economy and society and politics. My own work really, back when in governments, markets, and growth, was really about the political transformation that facilitated the kinds of economic growth that then took place, about how, in fact, French economic growth in very powerful ways hinged on the ability to suppress the peasants while everything else was going on. And de Gaulle's great strategy was to hold them in line while the marketplace wiped them out. But that's a very interesting part of the story is this is structural transformation. Structural economic transformations are political transformations that are often extremely dramatic. And so the question partly, and I'll come to that in a moment, is, and that's what drives the productivity, is in fact, what are those structural changes now? Part of those structural changes, I should say, and people are too quick about the movement to services in this industry, in these industries, is that the ICT world, information technology world, has transformed services as powerfully as it has transformed everything else. And there are huge gains in productivity that come as a result of that. But that's a longer story, which leads quickly to where, what can the state do and what are the policy challenges? Well, I should say, since one wants to avoid having a discussion about the Russian economy, about which I know not much more than I heard today, that is, I really am not an expert on Russia and don't have any pretension to be. There are three areas. One is the state plays a major role in successful economies in the early stages of the technology, in the investments, in the R&D, the early R&D in universities, in the underlying technologies that are necessary. And in some cases, one can identify where those areas are. If you want to have a decentralized, if you want renewable energy, you must have a decentralized grid. No option. If you want a decentralized grid, it helps not only to have the ICT to manage it, but the storage technologies. So that in fact, investment in energy storage, research is a perfectly sensible thing to do. Secondly, the state has powerful impacts in demand by the things that it's going to do anyway, that are legitimated by its basic objectives and goals. And therefore it generates demand, and if it thinks through how it's generating demand, it can create demand for the technologies that are emerging. And lastly, of course, what are the right rules? Now, let me conclude by saying that there are, in my mind, two big challenges ahead as we think through what these structural transformations are going to have to be like. One is around this computation, abundant computing, and the second is around renewables. Around computation-intensive, abundant computing, what we really see is what I'm going to call computation-intensive automation. I'm intentionally using those words rather than AI and rather than machine learning, because both of those terms are semantically loaded. Both of those terms imply work will be displaced. Workers are gone. The robots are coming. There is a dystopia that's ahead. And the reality is we don't know how much work is going to be displaced. We don't know what all of the studies that have been done are somewhere between silly and misframed. So that in fact, we don't know how much work's going to be displaced. We don't know how much work's going to be created in creating all of these things, and we don't know how much work is going to be transformed. And when I say transformed, all of us, I'm sure it was true in Russia as well, 30 years ago when we entered the university, in fact, there were secretarial pools doing all the typing. And then along came Word, Microsoft Word, and it transformed the role of all of those people typing into being assistants, into changing the roles and functions that they had, and turned Knick and Jorge and myself into typists who did our own work. George, forgive me. Into doing our own typing, and the character of work was underneath it in very important ways transformed. So one of the important things for the state to do, in my view, is generate support to figure out how we use computation-intensive automation to augment skills and generate the collaboration of machines and people. We know it's possible, but right now the flavor of the day and the research of the day goes the other direction. So I'm going, wherever I speak, I'm proposing the Korea Prize or the Munich Prize or the Russia Prize to try and generate that kind of research. The second area is, of course, in energy. And here it's not simply a matter of whether or not you have a decentralized grid or whether you have storage and the like. The problem and the challenge, it's not just true in Russia, though more true in Russia than many other places, is fossil fuels are not only the basis on which we've organized economies, but they are also powerful economic and political interests. So that in fact, how does one in fact transform the character of those interests and turn them into advocates for renewable energy? What I would do in the United States, if it was I would give huge subsidies to every local oil station to be able to install electric energy chargers. In other words, you know, we've seen in the work we've done on what we call green spirals, how you generate alliances between groups that were not originally in support of renewable energy. You have to allow those who have stakes in the existing system in some ways to find ways in which they're going to be able to benefit from the next system, because they're not going to just all be displaced. So in any case, that's my narrative. The narrative is one, these technologies are not just about the investments narrowly in them, but about the change in the possibilities in the economy. The two broad areas are computation, abundance, and renewable energy. And the question is, how do we go about capturing those possibilities in all of our societies?
Thank you very much. That articulated some of the most important concerns of the day. Can I now give the floor to Anders Åslund?
Thank you very much. I should say I have just published a book together with Semyon Yankov that is called Europe's Growth Challenge. And one of our chapters is on innovation, which and high-tech development, which is, of course, one of the key factors for economic growth. And what we did in this chapter was that we looked upon what is the state of affairs in the 28 EU countries in comparison with particularly the United States, and what should be done. And generally the picture we get is that it looks pretty bad. You can roughly divide the European Union into three parts in these regards. Northern Europe, where you have half a dozen countries, which vary a bit, that are doing pretty well. Southern Europe and Eastern Europe that are both doing awfully poorly. And let me take here the 6 major aspects of innovation system. In order to have successful innovation, you need to have an ecosystem. And I would divide it for simplicity into 6 different parts. First, you need elite universities. Second, decent financing. Third, good rule of laws. Fourth, good regulation. Fifth, a good-sized market. And 6th point is internationalization and openness for qualified labor. So if we look upon the situation in Europe, what does it look like? The big shocker is how bad European universities are. Among the 25 best universities in the world, on the Shanghai list or the Times Higher Education list, there is not one single European university among the 25 best that is from the EU continent. You have a handful of excellent British universities. Britain has good universities, otherwise the rest are essentially American. You can get now a couple of Singaporean and a couple of Swiss universities, but not on the European Union continent. This is, of course, a massive task that needs to be done. And the shocking thing is that it's not an issue. It's not on the agenda that EU universities are so bad. The best come on 29th or 30th place in this list. So what is needed? More independence, more freedom, and more quality, and more internationalization. The second issue is financing. And here it's partly research and development financing in general and partly venture capital. With regard to research and development financing, there are half a dozen countries that are doing quite well. You can say you should have 3% of GDP, the US level to do well. Sweden and Finland are above it, and there are about 4 other countries that are similar levels, all East European, North Europeans. The East Europeans here are very low, at 1% of GDP and research and development. And Southern Europe is also surprisingly low. The worst problem when it comes to financing is venture capital. Venture capital has been the big success in Silicon Valley and generally in the US. Venture capital in Europe is very small. And this is a big problem. You don't take big risks with bank credits. Europe is dominated by bank financing. You take it with equity capital and specifically venture capital. And an added problem here is that 40% of European venture capital is state money. You don't take risks with state money, or you are changing your risks far too often to be successful. The third issue is property rights, intellectual property rights and rule of law. In general, I would say that the European Union has very good courts. This is one of the great achievements of the European Union, that the European Court of Justice has improved rule of law for the countries as a whole. The problem is rather how you distribute intellectual property rights around the universities, so that there is a sensible way for scholars to benefit from their intellectual property rights. And that specific issue should be relatively easy to solve, since US universities have done so easily. The fourth issue is regulation that has been discussed here, and this is difficult because it's many things that is regulation. For example, GMO is not accepted by and large in Europe. There are lots of regulations on biotechnology, and Uber here was mentioned simply what you can't do in Europe. And specifically also it's very difficult to scale up enterprises. The US, among the 50 biggest enterprises in Europe and the US, there are 3 times more enterprises in the US that have been created after World War II. There's far too little renewal of enterprises in Europe. What is happening is instead that the old enterprises buy up the new enterprises for a number of different reasons, mainly with regard to tax rules. So we don't have Google that was founded in 1998. Russia has Yandex. Yandex is a wonderful company, but what happens? It can't move out. And that's a fifth point, the size of the market. You might have heard here before Esquire, who spoke in the plenary about it, that Nokia was not beaten by Steve Jobs. It was beaten by there is no digital market in Europe. Nokia did well as long as phones were hardware. When phones became primarily software, Nokia and Ericsson lost out. And Europe urgently needs a unified, a single digital market. Today, if you travel around and want to watch Netflix, you need one Netflix subscription for each of the 28 countries in Europe, which makes no sense. And the similar is the service market. Manufacturing is old industry by and large. And the service market, only half of it is actually liberalized. Europe has officially a single service market. In reality, the service directive of 2006 looks like a Swiss cheese. It's full of holes, and on top of it, it's not very well implemented. For example, in Germany, you can't have a shop open on Sunday because of unholy alliance between the churches and the trade unions. Makes no sense. And these are things that Europeans should care about in order to open up markets. And then finally, the sixth point is internationalization. That in Silicon Valley, half of the enterprises have been created by foreign-born people. Europe is on a good way in this regard. So I don't think it's a big problem as it now is. The problem is that Europe is likely to go in the opposite direction. So what this shows is that Europe is not catching up with regard to the universities and the financing of the innovations. It could catch up quite well fast with regard to the markets. The digital market and services markets are on the Commission's agenda. I don't think it will happen. There's no political momentum. And on migration, it's a danger that it's going in the wrong direction. And with regard to regulation, this that you said here before, that don't ask for permission, ask for forgiveness. That is not a European thought, and it's not. It's likely that this specific point will make it ever worse for Europe, I'm afraid. Thank you.
Thanks very much, Anders. Can we also stay within Europe with you? Our next speaker is Mathilde Mesnard, Deputy Director for Financial and Enterprise Affairs at the OECD.
Thank you. I will try to be very short because I guess you're tired, and I landed also at 4 o'clock this morning, so I am tired. What I want to tell you, it's about a paper by some of my colleagues. It's not at all a book that I have written. It's my colleagues, especially Chiara Crisco-Olo and Dan Andrews, from our Science, Technology, Innovation and Economic Directorates. And what they have looked at is the dispersion of productivity at the micro level between like the frontier firms and the laggard firms. And what they have done is to show that there is a divergence since the beginning of this century between the frontier firms. I don't have the graph, but basically you see the frontier firm, the productivity going up, and the laggard firm like staying basically low. And this divergence is increasing with time. So the question is, what is behind this phenomenon? You see also that this divergence is bigger for the service sectors than for the manufacturing sectors, and it really begins in the 2000s. So that's quite a new phenomenon, and we need to figure out what's behind. And we don't have the answer yet, but we have some I would say, piste. And the first one is obviously the winner-takes-all dynamics at the frontier side of this divergence, for all the reasons that I guess you know all about the link to the ICT sector, etc. And this is maybe confirmed because if you look at the frontier firms and how we have done that, is that you take the 5% higher labor productivity firms. If you take only the 2%, the divergence is much bigger. So it seems to confirm this hypothesis that there is a winner-takes-all dynamics. So that it is well known and discussed in the literature, so I won't be long about that. But then the second point that is very interesting, it's what is behind this stagnating productivity at the bottom. And that's the problem of diffusion. You were mentioning that. So probably we have a problem with diffusion of innovation. And we have a lot of numbers that seems to support this hypothesis. It seems that the laggard firms are increasingly having difficulties in benefiting from the innovation at the frontier. And then a third element that could support this increasing divergence in productivity, it's a decline in contestability of markets, which is also a very big issue and a problem. So what I will do is to give you the title of this article, which is extremely interesting, and it's easy to remember. It's The Best and the Rest. So you type on the OECD website, The Best and the Rest, and you'll have all the analysis, all the data, etc. And just to give you a quick summary, so we think that the slowdown in average productivity growth masks an increasing divergence between the global frontier firms and the larger firms. And there are structural trends in the economy unleashing winner-takes-all dynamics and making adoption of new innovation more difficult. And this divergence in multi-factor productivity was partly inevitable, but also the policy framework didn't sufficiently adapt to these structural trends. I did not have time to develop that. But what's very worrisome is the evidence and declining market contestability. So that's the main points. I was very short, sorry. But go and read this paper, which is extremely interesting, The Best and the Rest. Yeah.
Certainly a great title. I look forward to reading it. Thank you very much. The next speaker, Chris, would you like to continue your remarks? Are you still here? Chris is not here. Okay. Our next speaker was...
No, I'm not sure. No, he's not here.
He was... Oh, well... yes, is Peter Kazakova, who is the director of the Center for Resources at the Academy of the National Economy under the president. Center for Resource Economics. Thank you. Thanks for coming, Peter. What? Yep. Do I have a slide switch? Oh,
that's
yes.
here.
Right.
Good evening, and I realize that I'm the last to speak. I speak in Russian, and I would like to say that I'm pleased that the first speaker at this launch session was professor of philosophy, and this session is concluded by professor in my person. And the last 2 years I realized that my first education was philosophical one, and it sounds differently with regard to the artificial intellect. But at the time when I was a student, and was some 18 years ago, and only philosophers and experts in cybernetics, they dealt with artificial intellect, but not economists. But the time has come, and everybody is dealing with this issue, and I'm glad about that. But in fact, it started being discussed not that long time ago, and I believe that you remember those pictures which made a world tour, and you see here a young man surrounded by security. You may think that this is a popular singer holding its press conference, but this is a young talent, Korean Lysidon. I would call him a great combinator, but not as a Ostap Bender, but Greco, where he became a champion. And he is very sure of himself, surrounded by security, and at the same time, in the right picture, you see that he lost his game against the artificial intellect, and this information make a stir in the mass media, and he was much spoken about, and it was shown that the artificial intellect reached our house. And I raised the question for myself, what about artificial intellect when it reaches oil and gas? Because I'm dealing with oil and gas industry, and I'm interested what new technologies may make a breakthrough in this industry. I won't lecture you on all developments in this industry, but I wanted to intrigue you because I'm intrigued myself by this topic and to see where these new technologies can be employed and in what way it will touch upon us morally and ethical way. And the fact, with regard to energy, I invented a very beautiful abbreviation, OGAI. And in Russian, I call it digitizing of oil. I will tell you in 2 words what is happening currently and in what way it may influence us. Well, I will be very brief with regard to artificial intellect. Neuron network. In fact, it is a system of data processing. So on the one end of neurons, the data enters and then it is processed and interpreted. The principal difference, every neuron is a microprocessor. As in old way of processing the information, this is a processor, but there's an important difference, and it is in the fact that neurons are not programmed, but like brains, they are taught. They are not programmed, but they are taught. And the more information is processed by this by these neurons, the same as a human being. With the education, he acquires much more knowledge, and he can use this knowledge for the information processing. And the same goes true for neurons. It goes beyond its creator, and if will be done on a mass basis, this will be a technological revolution. What happens in oil and gas industry, in energy as a whole? I will speak mostly about oil and gas because this is a topic close to me, but this goes true for alternative energy as well. Recently, I met a programmer who is dealing with the use of artificial neutrons for windmills, in what way they are run. But most of the research is done in oil and gas industry. Let us see what is there. This is the very good and fortunate time to make these studies, and because the oil businessmen, they are hungry because the price on oil went down from more than $100 a barrel and now to $55. And those transformations which happened before 2014, they were innovations which were, we can say, satired, which depended on a large income. Now what we have is hungry innovations, which earlier innovations were venture capital, which made tests with shale oil drilling and so on, horizontal drilling and seismic prospection, and then there was a breakthrough. That was done at the higher level of price per barrel, but now the oil businessmen, they are looking for cutting their expenses, and because first of all they cut their stuff, whether we like it or not. But oil industry is not the most worker-intensive industry. But even with that situation, there's a cut in workforce. We see 4 spheres where we have breakthroughs with the use of artificial intellect at this period of hungry oil businessmen, and 3 of them are linked to oil and gas business, and the other one is linked to corporative governance. First of all, this is geological prospection. Just imagine that a geologist is sitting before the computer and looks at the fracture of various layers of and extrapolates his experience with the previous experience, just to understand how much oil can be extracted and how much it will be spent on that extraction. And then he sits down with economists and makes final calculations. Nowadays, if we happen to do that through artificial intellectual, we will see the global oil deposits, and there will be not one geologist, but all the knowledge will be combined, and this will stimulate the analysis, then extraction. Again, the human factor is brought down. The automation replaces the human beings. And the yield of every deposit, there are less boreholes and more effective wells. Next aspect, this is transportation, and transportation by sea and by oil pipes. What is the most important factor is the oil spills from tankers and in pipes. Again, this is not analysis, but the prevention of catastrophes, not reaction to them, but.
And the last one is the prevention of accidents, where these technologies can become helpful. Then analysis of market, the forecast of prices. Nobody could have foreseen the black swan as the slump in oil prices. Everybody knew that the price would be increased and everything will be all right. Then the price fell down, and now you have new methods of forecast, neuron networks, artificial intellect, and the semantic analysis of news bulletin in order to determine the market trends, where the price is going. On our part, the Center of Commodity Economies, Dina, Nicola, and Rafael, my colleagues, were interested. Innovations are very uneven, but someone has, in the final analysis, to the inventory, someone has to analyze. The shale revolution did not have it. It was not going to be televised. We didn't know when the revolution will take place. We don't say that we will know when it takes place with the artificial intellect, but we'll track all the new trends. We have compiled a map of all the main players who are using artificial intellect, oil and gas companies, the service companies, and consulting companies, Deloitte and Touche, and academic institutions, think tanks, and a group of scientists like us who are also dealing with the new technologies. Are there examples of this in Russia? Yes, there are, but they are not numerous. what is interesting, that all the three examples concern the cooperation with foreign companies. These are like joint endeavors or projects, Shell and Gazprom Neft, Sakhalin Energy, Gazprom Shell, and two Japanese companies, Mitsui and Mitsubishi. Sakhalin is the only region where Russia is dealing with liquid gas. And these companies using the technology of digital smart wells. And Lukoil, that is experimenting with the artificial intellect in foreign projects in Kazakhstan, Iraq. And that is probably will not be the end of it. You will ask me why the shale revolution took place in the United States. The United States does not have the largest deposits of shale oil. Russia has much larger reserves, but the revolution did not take place in Russia. Its sources are institutional, and this is very important. So I want to advertise my publication. Only the day before yesterday, the Caton Institute in the United States published my report, which is called Curse or Blessing. In this report, I'm trying to provide an answer to this question. Why the strong institutions can support innovations in these economies, although they are considered to be low innovational. In conclusion, I will cite from a man who was one of the founders of artificial intelligence laboratory, Alan Newell, who founded artificial intelligence laboratory at Carnegie Mellon University. Unfortunately, he is deceased, has passed away. He said that we'll see the real history of artificial intelligence with maximum objectivity, but the time has not come yet. So I think he said it in 1982. 25 years later, we are 35 years later. We can see that this time is approaching. And this history will be written by us, thanks to the pioneers like him.
Somehow. I'd like to thank you, the audience and the speakers, for your enormous patience. This has been difficult in the planning stage, and I now see in the execution stage, probably necessary to take a break, but let's not do that. Let's move right into questions to somehow bring together some of these policy implications which were not made, say, Knick and Alessandro did not make any policy suggestions, although they wanted us to look differently at what amounts to technological progress and how it might be achieved. Anders has a specific set of suggestions, and we also have, Professor Zysman, you have these two major areas of computational strength and renewables. To what extent are these suggested directions being realized? I think we have, from Anders, we have something of a pessimistic approach, especially in regards to the creation of an ecosystem through universities. I think I didn't get that from Professor Zysman. I think I got a more optimistic approach, if I'm really right. And perhaps we can start off again with, you were so wonderful in just talking for just a few minutes. Mathilde, might you give some, just a fresh comment, optimism, pessimism, at least for your area, about whether this ecosystem that has been that we've been talking about, the production of an ecosystem which is flexible, adjustable, open to transformation and consists of these responsive people, is that being created? Is it on the agenda?
At the OECD, we want to be optimistic, but because we consider that's a great opportunities, all these changes, but provided that you put the right policy framework in place. And the problem is that, as is shown in this paper that I was referring to, is that we are not sure yet that we understand all of the drivers of this productivity divergence. So we have some clues, for example, regarding the competition policy that probably we need to adjust a lot, are the main frames in which we think the competition policy, especially with the digital economy. So we have some clues of problems in our policy frameworks, but we are not yet sure. But definitely we want to use, I mean, let's say this digital age, you know, as a focus on opportunities, provided that we adjust our policies. And because we have big challenges in terms of policy, in terms of inclusiveness, digital divide, etc., and in terms of competition, etc. So, and I would tend to agree with what you said at the beginning, like the role of the state is quite important in adjusting the whole ecosystem, you know, all ecosystems, and to cooperate on the, of course, obviously, it's kind of an obvious answer, but this cannot be done at one country level, and that's what makes it quite difficult.
John, yes, John, do you have a comment?
Comment on this. I must say that I've integrated the best of the rest into my remarks tomorrow. So I really want to say I think it's a very important study. I think it's important that two things need to be done. One is we need to validate those results so they're not easily challenged, because at the moment a number of people will say to me, well, how valid, how robust are those results, because they're very significant. And secondly, work through what, as you're saying, the sources are. And I've been talking to Krista about how to do that, about some approaches to doing that. But I think that this issue of you know, what are the reasons for that is really one additional part, is that there may well be a global maldistribution. That is, the value that's created by Apple in Silicon Valley, capturing the design, leaving to Shenzhen and the firms with, because for those of you who know that it's not just the top 10% versus the rest. It's the top 10% sector by sector. So it's not like there's a lead sector where this is really very powerful and some trailers. It's within the sectors. So I would leave my remarks aside, but to urge folks to really take a look at this. And in the computation issue, the question is how to generate those capacities and the ability to apply them. I'm much more pessimistic, and I have this argument with my friends out of the IT companies on an ongoing basis, and we're actually trying to put together a systematic project to look at what are the real possibilities and what are the real limits of some of these kinds of tools. It's an argument that I have at the moment with Stuart Russell at Berkeley, if you know Stuart Russell, who's, you know, so it's a very important issue. On the oil and gas issue, the question is, from a Russian standpoint, a lot of these approaches are, as you say, are part of joint ventures. So the question is, why? What can Russia do to, in fact, whether it's AI or it's just other computation approaches, to basically be able to integrate those into its own companies so that it's not as dependent on foreign intellectual property, because that's a heavy basis, not just the money on what those deals are about. But that's clear to you, I'm sure.
Thank you. Anders, do you have a comment? A question, of course, yes. Do speak into the mic. We need a mic.
Sure. Who is he? Do you know who this guy is? I tend to shut.
У меня первый вопрос.
I have the first question. You spoke about regrets about innovation process being uncoordinated. How can we coordinate the process of diffusion of innovation? Or we need to create general conditions for their development. And when they reach critical mass, then the synergy will be reached by itself. How this process is going to develop? I can answer this question, general conditions. And the second question. I regret on the cool policy of the United States vis-à-vis Silicon Valley. There is a concept, national concept of increased productivity of labor. What place is played by Silicon Valley in this concept? The answer is no, no place.
I'm not sure I understood the question, but the issue
Yeah.
of diffusion technology, if you take American agriculture, there's
Если взять американское сельское
service. There are a whole array of mechanisms. If you take Japanese machine tools, the Japanese NC machine tool centers have very important. There are a whole variety of diffusional mechanisms that exist in a number of countries that have been extremely effective, which require proper conditions. We don't disagree about that, but which also exist. The Silicon Valley question, neither or I understood the question, so we'll let it go. It's late.
Well, you know, the focus on urban policies as a source of potential productivity expansion seems to me is important as well. That London's suddenly it's becoming possible through its associations that it might not be as subject to the Brexit as the rest of the country. So there's a sense in which there's a lot we don't know about the urban concentration and what that can provide to productivity improvement.
У меня вопрос ко всем участникам, кто больше знаком с проблемой.
I have a question to all the participants who are prepared to answer. This was caused by Ivan's presentation. I don't know. Don't you think that for some of the regions of our country or Ukraine, technological challenges and drive in technological development are part of gray economy, and even black economy? What do you think? What percentage, what share from the point of view of macroeconomics? Do you have any kind of statistics in this respect? Of course, it is naive to speak about statistics, but maybe you have this kind of research. Do you understand my question? Can I answer? I have seen a number of papers. You are talking about gray economy, what is written by Kardonsky. The garage economy, he calls it. The gray economy is considered in world-class research. The qualities of the shadow economy. There is unqualified human capital, simple services, simple goods, and I am afraid this sector, it will be difficult to get diversification. On the contrary, the greater share of gray economy is a sign of degradation and crisis.
To have a strong, innovative economy, you need to have strong property rights. The gray economy is the opposite of strong property rights.
Я бы тоже хотел добавить и несколько не согласиться с Иваном, потому что я считаю, что...
I do not agree with Ivan. Part of the innovations came from the gray sphere, not from Uber and Airbnb started as untaxable, and they are still criticized for this. So we can't say that innovation should be wide. Very soon we will see white and black, white and gray merge when innovations reach great tempo. We will stop understanding what is gray and what is white. As far as economics related to my subject, in energy sector, the greatest innovations are not in where government regulates, but not where government subsidizes. Alternative energy was subsidized for years, but shale revolution took place. But soon, how soon is soon? Is it 20, 30 years? Следующему вопросу.
Я про размыв государства и...
Александра, могу я вас спросить, что произошло с микрофоном? Возвращаясь к имущественным правам. Конечно, это возможно, но интеллектуальные имущественные права, у меня не было времени говорить об этом в своем докладе, но у нас есть свидетельства некоторые коллеги говорят, что это чаще работает как налог на изобретение. Поэтому давайте осторожность проявим. У нас есть также...
Shale revolution, for example, it happened without patents in the United States, and it is a big development, it is an important technology. So, on the issue of intellectual property rights, I would recommend some cautions on that. Okay.
The new Canadian foreign minister, who is trade minister, agrees with you 100%. I mean, that's the Canadian negotiating position about TPP.
And the OECD also, like officially we are not really yet allowed to say so, but we want to consider this intellectual property right aspect. And we think that the current regime might not be the best one, yeah.
We had a question up there. Do you have your... Yeah.
Thank you. Yes. My name is Kendrick White. I'm the advisor to the rector of Lobachevsky University. And I want to tap into the idea of the commodity-driven economy and whether that's a benefit or a curse. And I want to tap into the idea of how that affects the development of the innovation ecosystems in Russia. If we look at a book done by Lauren Graham several years ago called Lonely Ideas, it's absolutely clear Russia creates terrific innovation, but it doesn't have a successful track record in commercializing that. And I think the reason lies directly in the fact that this has been the commodity-driven economy, which creates an extremely short-term mentality in both the private investors as well as government support programs. I'm working right now on a program called University 3.0, which is to address modernizing university tech transfer infrastructure. And I think this is actually the answer to Russia's problem in creating the innovation economy. Because speaking about many Russian universities, They have a tech transfer function, but it does not assess the commercial viability of that technology. It does not support translational research moving from an idea phase over to a practical application which can be presented to industry. Now, 10 years ago, Russia was just trying to address this issue of creating the innovation economy with technoparks. Today, this topic is very hot. Here's the problem. Because of this commodity-driven economy and the mentality of the budget rules according to the Russian government, looking at a modernization of Russian university tech transfer, they're looking at a 3-year program which would give money to universities but require that they immediately begin to generate revenues from spin-out companies. This is crazy. This isn't going to work. If you want to support tech transfer and commercialization, there needs to be a better 10-year horizon in the government support programs. So my question to the distinguished panel, is Russia going to be able to take this leap of faith and adjust its institutional approach to modernization and reform to begin to take a long-term view rather than the short-term, quick revenue-generating scheme? Because to create the innovation economy and develop nano products, new materials, advanced science projects, not only IT projects, it has to take a long-term horizon to be able to develop those projects, encourage with tax incentives business angels to support those projects, and finally to really incentivize corporations in Russia to buy those technologies rather than just going and buying them off the shelf internationally, so that there's a domestic market. Thank you very much.
Thank you so much. Is there a response to that? Yes.
I think it's a brilliant question, and the paper I mentioned is answering exactly that question. Is it a curse? And it's called Curse or Blessing. You just Google it under my name. And it's trying to answer exactly that question. Is resource abundance a curse itself? And I argue it isn't. What is the curse is the quality of institutions if it's low. And to answer your question, why doesn't Russia go from having lots of scientific inventions to commercializing them like other countries do? And actually we see that other countries commercialize some of Russian innovations in science. And why is it the case? Is it because of oil? Well, I think the government often wants us to believe it's because of oil, because it's an easy answer. You know, something didn't work in 1991, something didn't work in 1998, something didn't work in 2008. What is the reason? Resource curse. It's a very easy answer, but it is the wrong one. I think and I agree with you, it's short-termism which is the real problem. But short-termism is created by people being, in entrepreneurship being intruded by government for so many centuries. So there is no institutional trust in the system. If you remove part of this intrusion and obstacles in the form of bureaucracy, then you might see some results. And if you look at countries like Canada, Australia, Norway, Malaysia, they have no problems transferring innovation into results while being resource economies to a large degree.
But you still need the government support at the earliest stage. For example, if you look at the Deshpande Center at MIT, this takes a long-term view of supporting the proof of concept stage. And I think the problem really is the young innovation entrepreneurs, they don't see the hope of realizing their ideas in Russia, and therefore we have the brain drain. So they leave for Silicon Valley and they leave elsewhere. We have to develop mechanisms at the Russian universities themselves that support the hope that those innovators can create their businesses here rather than leaving.
I agree, but I think the blockage is not at the university level. Look at this university. It's a brilliant school. And other schools, the Higher School of Economics, the Moscow State University, my alma mater, and others. They're brilliant schools. And then people go all over the world. The blockage is at the later stage, at the stage of the economy and its institutional design. That's the problem. And it's not oil either. It's that institutional component which is a problem.
Let me call on Anders, who had also remarked to this.
Yeah, I have a slightly different take on it. If you take the 17 countries in the world that has the largest share of energy rents in their GDP, they're all authoritarian. The 18th is Norway. So oil is a curse. And it's very difficult to get away from it. And it's easy to understand why. You get large rents that are concentrated and can then either be taken by the state or by the ruling elite. And normally both things happen in the oil-dominated states. So the lower the oil price, the better for Russia's rule of law. And the good news for Russia is that it's the 17th state in terms of shares. So Russia is at the tipping point. So you would expect that the probability of better governance would increase if the oil price is low, as we saw in the 1990s. And that follows, from that follows the bad governance when it comes to rule of law and also isolation. I think that the current rules on making it difficult to travel, I mean, Russia has one of the more difficult visa regulations. That, of course, blocks a lot. The sanctions, of course, aggravates all these bad tendencies. And now we have very much digital isolation, that you have to keep databases in Russia and you have to keep them available to the state. And all this complicates, but the fundamental thing is if you have a lot of oil range, you naturally have a lot of state dominance and you have naturally poor governance. And then I completely agree on Canada, Norway, and Australia. So you can get out of it if you manage in one way or the other, but it's not easy.
I'm going to make a strong suggestion, which is this is a very rich and fruitful topic for the next Gaidar Forum. And that at that point we can take a look. I come from a place that's rather centered around that, and my university has its own issues. But I don't think we're going to resolve this question in a few minutes. So why don't we take it up? If you, the next time you have one, you may want to design a topic around that.
We did have one very patient person up there who has a question.
Yeah, in Russian or in English?
You don't have a...
Okay, I will ask my question.
no, behind you. I'm sorry, up there.
Why don't we take anything all together?
Take both.
Both. Take both? Both?
Together we each get 1 minute.
In fact, no, I was. It's just a few learned footnotes, but I think they may be of relevance. Let me start with best and the rest. The OECD has actually a pedigree on this because Angus Madison, who has written in some of the issues here about comparisons of economic growth, has a book that's quite successful. It was written about 10 years ago, and the name is The West and the Rest. Now, of course, we can say you wish, because, of course, the West is not what it used to be. That's the first footnote. I think Mathilde's idea is quite relevant for the other points. And there's, again, a literature, I'm thinking in particular of Mariana Mazzucato's Entrepreneurial State, which go exactly in that direction, but they show that the state can really make a big difference at the beginning if it knows then how to retreat. And you cannot guarantee this, and this is really the difficulty. And so what I offered in what I tried to present yesterday on this is finding ways of increasing the quality of policy design and its execution. The sad thing is that in the European Union, you don't have peer review systems that manage to combine the sectorial dimension and the international one. So the quality of policy has made reforms far less sustainable than they ought to be. But about the universities, and lest we get too excited about what they can do, there's a legend at MIT by Paul Samuelson that right in the post-war era, there was, as you know, a big financing of all universities in the US. And Samuelson threatened to resign from MIT. At the time, the economics department was very small. If it was going to be distributed equally, he said, no, we give it, well, first to MIT because that's the best according to his view. But the fact is that it was done in this way. In Europe, that cannot be done. I mean, there was this attempt at the European Institute of Technology, so there's an issue that I'd like to bring out, and thank you for your patience. Let me give you back your mic. Oh, you.
Yes, you.
Oh, In Russian or in English? My question and one remark goes to Peter Kazachiev. Well, the question is, at the moment, the oil and gas industry is at the beginning of the new investment cycle. What is actually the share of investment for innovation for artificial intelligence you mentioned, actually? It's your estimation. And the remark is, you said actually that this black swan with falling oil prices, it was hardly predictable. Yes, oil prices are very volatile and hardly predictable, but all we know that there were some mega trends like shale revolution and so on, and maybe we should speak about that. For instance, Russia also underestimated these global trends, and what we see at the moment is just not the oil and gas unpredictability, but bad calculations by some who are actually in charge of these mega trends.
Very, very quickly, please.
Absolutely. Yeah, I don't know the share of investment going into artificial intelligence. We don't even know what exactly is happening fully. We're just trying to map it. We're at the very early stage. A. B, I would add, it's not just artificial intelligence. Don't bank just on one innovation. We might find ourselves in a sharing economy of oil and gas next 10 years from now, or something like this. Who could anticipate the concept of Airbnb applied to real estate? Suddenly it booms. You know, something like this can happen, and we don't even know what it's going to be. So it may be blockchain or something else. And finally, on the forecasts, I work on economic forecasts, but what I would say the key is an institutional solution. You will never be able to predict what the price is going to be. You can look at scenarios, you can look at, corridors. That's useful for trading, for companies. But essentially, what is really essential is that you make a living as a country, as an economy, and you generate revenue under different oil prices, that your institutional system is strong enough to adjust. And that's exactly what happened in a number of countries. We had a separate study on this. If you're interested, go to our website. We have it on how economies adjusted to low oil prices. And some did exceptionally well in the 80s. And that's the example that we should learn from. It's less about forecasting, I think.
Thank you very much. I really have to bring this to an end. We're now well over time. The most important thing is to thank you for your attention, wonderful questions, and to the participants as well. Remarkable things happen at the end. And to those on economic growth, it was great, and I loved the history papers. So thanks so much to all of you.